morning everyone. In this class we are going to learn about computer science. The subject code is 0478 and today topic is problem solving and programming, mainly concentrating in grade 10 students. So before starting this topic, I want to tell you about the importance of the topics. So in paper 2 you have two sessions. One is part A and second one is part B. So part A consists of a pre-release material which is for 20 marks, and part B consists of flowchart, drawing, tracing, algorithm writing, error finding, match the following questions, and one loop structure to another loop structure, test data, databases, validation, verification, and programming concepts. All together you will get 30 marks and 20 marks is the pre-release material question. Pre-release material will be provided by the Cambridge University by the end of June. So all the students are asked to complete this task before your O-level examination. So now just start the objective of today's lesson. Today we are going to talk about algorithms, because algorithm is an important part to solve the 20 marks questions, and the pseudocodes and the flowchart symbols and drawings, and how can you produce the algorithm using different stages, and the sample exercises of flowchart and algorithms. Just start with the topic algorithm. So algorithm, you all are familiar with the term algorithm. Algorithm is a step-by-step procedure to solve a problem. Every problem can be solved using algorithms. Even your mathematical problems, your day-to-day problems, all the problems can be described in step-by-step procedure. So in definition, algorithms are a finite set of steps taken to solve a problem. So it's a collection of steps. And this algorithm can be represented using two ways. One is pseudocode, which is also called as a text, and the second one is a flowchart, which is also represented in graphical form. Now, what is a pseudocode? You also will be familiar about this word pseudocode. Pseudocodes are used structure English to describe the algorithm. Every algorithm can be described using pseudocodes. And again, one more definition about pseudocode. Statements are written in free-flowing English, although some keywords normally written in uppercases. In pseudocode, some of the keywords you can write in uppercase. Next slide, I will show you an example of a pseudocode. Just see this pseudocode, don't worry about the codes, it is only an example. I want you to know about what is a pseudocode. In detail, we will be describing this pseudocode in coming units. So here you can see some of the commands are in capital letters. You can see input, one example, if, one example, then, one example, print, one example, else, another example, print. These are the important words, or we call it as keywords. We call it as keywords in pseudocode. Okay? So this is a small example of pseudocode. Now, we already learned what is an algorithm. Algorithm is a step-by-step procedure to solve a problem. Now, how can we write an algorithm? Just see the different stages we produce algorithms. The first stage is make sure that the problem is clearly specified. For example, you are going to make a software for your school. So your problem will be your school. Okay, it's correctly specified. Your problem is your school. So you make sure that the problem is clearly specified. And break the problem down into sub-programs, because if I ask you to do a software for your school, it's very hard task for you. You have to divide the all program to different modules. So modules, for example, in a school, the modules are teachers, one module, staff, the non-teaching staff, the principals, and the leading teachers. Those things are the different modules in a school. So you are going to break down the large program into different sub modules. So easy you can handle it. So breaking down the large complex task into small modules is called as top-down design. Top-down design, one more point for you, please note down. The breakdown the large complex program into small modules is called as top-down design. Now the third step says decide on how any data is to be obtained and stored. What is going to happen to the data and how any results are going to be displayed. You have to be planned how you are going to collect your data and how the results should be and how you analyze your data. Everything should be planned before you start the algorithm. And next step is you have to decide how to construct your algorithm. I already explained to you there are two steps to construct your algorithm. One is a pseudocode, second one is a flowchart. Construct your algorithm making sure that it can be easily read and understood by someone else. This involves setting it out clearly and using a meaningful names for any data stores. You have to be very clear about providing meaningful names for the values, or whatever you are going to write, it should be in meaningful names. Use several set of test data. This topic you will be learning in detail coming units. So after completing each module, you have to test your algorithm whether it is working properly or not. So you can test your algorithm by using different types of test data, and you can create a trace table to find any errors. And if any errors are found, repeat the process until you think that your algorithm works perfectly. So you have to continue the process until your algorithm works perfectly. So these stages you have to make sure that before you write your algorithms. Hope you clear. Now moving on to the next part, that is a sample algorithm I am going to explain to you. Just see the question. Write an algorithm using pseudocode to add two numbers. You can write an algorithm now using pseudocode to add two numbers. Algorithm can be written using pseudocode and flowchart. There are two methods. One is a pseudocode, second one is a flowchart. Now your question is, your problem is specified here. Your problem is add two numbers. You are going to add two numbers. If you want to add two numbers, you need two numbers. So I'm going to show step-by-step procedure for you. So every algorithm, the first step will be start. Start will be your first step. So you can write step 1, start. And step 2, input num1, num2. As I told you at the previous slide, we have to give meaningful names. So num1 and num2 are the meaningful name for the values. So num1 meaning the first value, num2 meaning the second value. Now here you can see one input statement over here. I just put in a red color. So meaning that it is a keyword, it is important, or it's a command. Now you can replace this command using another statement called read. If you don't want to use input, you can use the statement called read, also fine. Now the step 3 says you are adding num1 and num2 and store to the variable called sum. Now I introduce a name called variables. So what is a variable? Variables are symbols or letters which is used to store the values. So in this example, sum is a variable because sum consists of addition of num1 and num2. Num1 also a variable, num2 also a variable, but input is a statement. Now you can see there is one arrow mark over there. You can replace the arrow mark by using a equal sign. So you can use the equal sign also in place of the arrow mark. Output sum. Output also it is in a red color, meaning it's a keyword. Okay, output is a keyword. So you can replace the output by using the keyword print or write. Either you can use a print statement or write statement. You can replace output statement. This is a very simple example of an algorithm. Here I already explained to you num1 and num2 are the variables which is used in this algorithm. So in exam, in O-level exam, they will ask what are the variables used in this algorithm. So you can just say answer num1 and num2 are the variables used in this algorithm. Input and output are the different statements used in this algorithm. Now see another example, second example, just see. It's a normal algorithm, very familiar to you, you used to do with your calculators. How to convert your rupiah with dollars. When the dollar will be the input, how to find out the rupiah value. Now the first step will be start, you know that. Now the second step is input dollar. You are going to input the value of dollar. In this case, dollar is a variable, input is a statement. And rupiah, you are calculating the rupiah, equation has given here. Rupiah you are calculating by multiplying with 15.42 with the dollar, you are getting the rupiah value. Output dollar, the value will be output here, output dollar using an output symbol. If you don't want to use output, you can write it print also, fine, and stop it. This is also a basic algorithm. Now in this part also there are one variable used in this algorithm, so the answer will be dollar. So dollar will be the variable used in this algorithm. Okay, just see, you have seen two algorithms. Now just see the features of the algorithms. Very simple, you all are familiar with it. You can write the algorithm by your hand, that's the first feature, just you have seen now. And it's English like statement, but there won't be any paragraphs. You can just see that only all the connections are in commands. And clear and precise, everything is clear and precise, and give correct solutions in all cases. Most of the cases it provide you the accurate solutions. And few advantages also, less cumbersome and less time consuming, very less time needed to write the algorithms, and it is very easy to change. If you have any mistakes in the algorithm, or if you have any mistakes in your concern, you can change it. Clear and precise, already I told previously. Easy to program using a pseudocode. To write programs using a pseudocode is very easy. And it is easily readable, because the previous algorithms you have seen easily, you can read all the statements I have written. So easily readable statements. Okay, that's all about algorithms. Just talk about flowcharts. So algorithm, I explained how to write pseudo algorithms can be written using two ways. One is a pseudocode, second one is a flowchart. Just see how flowchart works. Flowchart is a diagrammatic representation of an algorithm. Algorithm can be diagrammatically represented or graphically represented using a flowcharts. Now these are the symbols. I am going to introduce some of the symbols used in this flowchart. The first symbol is start, or it is also used for the purpose of end. It's an ellipse. It's a parallelogram for input and output statements, and for process we can use a rectangle, and decisions has to be taken by using a rhombus, and the connections are given by using a flow statements. So these are the important symbols used in flowcharts. Again, what is a flowchart? Flowchart is a diagrammatic representation of an algorithm or a pictorial representation of an algorithm. Now see an example of a flowchart. So just the same questions before we have done the question in a different way. So before that I want to tell you that algorithm can be written in many ways. That is depends on the school or depends on the person. You also can write algorithm. Your algorithm will be totally different from your friends. So you can write your own algorithms your own way. Just see, this is an example. Output the sum of two numbers. How to find the sum of two numbers? I am going to show in a flowchart way. See, the first you are going to give the inputs. I already told you inputs can be given using a parallelogram. So input A, B. In this case A and B is a variable and input is a statement. And you are going to find the sum. Sum is A plus B. You are adding A and B and store to the variable sum. and you are going to find the output of that value, that is sum, will be stored there, and the rest of the parts will be same. And why I am showing this is at last is, this part is not necessary to write every flowchart, because this is the initial value of the variables. So, initial value means the starting value. Starting value of sum is 0, starting value of A is 0, starting value of B is 0. So, it is not necessary to write in all the flowcharts. So, I just keep this part last. So, again I am telling you, this is your input value, input A comma B, A and B are the variables here. Sum equal to A plus B, that is adding A and B, storing to the value sum, and you are finding the output and initializing the value, sum equal to 0, A equal to 0, B equal to 0, and finally you have start. So, this is a small example of how a flowchart look like. Now, just see another example. Just want to know whether a student is pass or fail in an examination. So, the condition is, if a student get above 50 marks, he is pass. If the student get below 50 mark, he is fail. Just see that one. The first part is the input mark. You are going to input mark, and once you input mark, you are going to check whether that mark is greater than 50 or not. So, these cases you have to use a rhombus, because rhombus will give you two answers. One is a true and second one is a false, or yes or no. If or is the mark is greater than 50, the entered mark, whatever you input, the input mark is greater than 50, so the answer will be pass. The student is pass in the test. If you suppose you entered 30, 30 is greater than or equal to 50. No, 30 is not greater than or equal to 50. So, the answer will be output fail. Take one more example. You entered 75. 75 greater than or equal to 50. Yes, 75 is greater than or equal to 50. So, output will be pass. 75, another value is 30. 30 is greater than or equal to 50. No, 30 is not greater than or equal to 50. So, the answer will be fail. This is also one small example how to write an algorithm. Here also mark I have set 0. The reason is the initial value of all the variables should be 0. That is the reason I set mark as 0. Now, in this flow chart, you can say mark is a variable, input is a statement. Okay? Mark is a variable and input is a statement. Variables are symbols used to store values during algorithms. Now, one more question from the drawing flow chart. This question asked once in O level. Draw a flow chart which will input a number, print the number is positive, negative or neutral. Just say input num. So, already you know how to give, that is in the parallelogram, and you are checking is number greater than 0. Say you input 5. For example, you input the value 5. 5 greater than 0. Is it 5 greater than 0? Yes, 5 is greater than 0. So, it is positive. Think you input minus 2. Minus 2 is less than, minus 2 greater than, first it will check here. Is minus 2 greater than 0? No. It will go here. No. Again here, is minus 2 equal to 0? No. If minus 2 equal to 0 means it will say neutral number. Minus 2 equal to 0 is no, so it will say negative. So, again I will give an example. Say 10. 10 greater than 0. 10 greater than 0. Yes, 10 is greater than 0, so it is a positive number. Okay? Now, 0, you input 0. 0 greater than 0. No. 0 equal to 0. Yes. So, it is a neutral value. And you input minus 3. Minus 3 greater than 0. No. Minus 3 equal to 0. No. Minus 3 is equal to 0. So, if it is, these conditions are not matching, the answer will be negative. Okay. This is also an example of a flow chart, how to check a number is positive, negative or neutral. Now here also I have given the value of num is initialized as 0 because the starting value of num is 0. Okay. Now you have learnt about two things, one is algorithm, second one is a flowchart. So again a brief, algorithm is a step by step procedure to solve a problem. Flowchart is the diagrammatic representation of an algorithm. Now see the common differences you find in the previous examples. Flowchart you can draw, but algorithm you can write. And here flowchart can be represented using diagrams. You have seen lot of diagrams before. And pseudocode is a English like statement. And flowchart is very easy to understand because it uses symbols, and difficult to understand because it uses structures. More space needed. In flowchart we need more space to draw, but here in pseudocode less spaces are needed. At the beginners, flowchart is easy to find or easy to solve, and expert find it easy when it is pseudocode. So the main thing is here, if you have a large complex program, it is very hard to draw a flowchart because it will be so lengthy. Flowchart, it's hard to change. If you have anything to change in the flowchart, it's so difficult in flowchart, but algorithm it is easy to change the concepts. Now this is also a introduction of trace table. In O-level examination 7 marks questions you will get. So you can see a lot of questions in the past paper, paper 2, but right now you cannot solve it. So just see a small example how the trace table works. Okay. Now before starting this one, I will show you another example of a trace table. Trace table is also called as dry run. Dry run means we can provide some inputs to the flowchart and you can get the results. Just see here the example question, output the sum of two numbers. Just I will show the flowchart already, we have done the flowchart here. So start, sum equal to 0, the first value of A is at initial 0, B is also 0, input A comma B, A and B are the two variables, it can accept any values, okay. Sum equal to A plus B, and you are going to output the sum and stop. And I am going to check this flowchart, I am going to test this flowchart using this test data. So the first value, meaning the value of A is 10 and the value of B is 24. Now see, this is a trace table. Here you can see the value of A, this is B, this is your sum value and this is your output. Now see the first, the value sum, this meaning if you have a sum equal, in maths we will say sum equal to 0, but in computer science meaning of this statement is the value of 0 is passed to the variable sum, okay. A equal to 0 meaning the value of 0 is passed to the variable A. B equal to 0 meaning value of 0 is passed to the variable B. Now here sum equal to 0, so just say the initial value is sum is 0. Now again A equal to 0, just start A equal to 0, B equal to 0, just write B equal to 0. Then next is input A comma B. I already told you the value of A is 10 and the value of B is 24. So input A is 10, 10 will go here, and B is 24, 24 will be taken to B. Now you have the value of A is 10 and value of B is 24. Sum equals A plus B. You are trying to add 24 with 10. So that is your sum value, 24 plus 10, that is 34. Okay. Then in this case, normally the students do a big mistake. Always you are trying to write the answer here. That's a wrong case. Okay. The answer should be here at the last. So here the answer will be 34. Adding 10 plus 24, the answer is 34. So this is a simple example of a trace table. You can check in the past paper, there are a lot of questions in paper 2 and you can solve it. This is how the trace table works. It is also called as dry run. Now to this session, the conclusion is we learned about algorithm first. Algorithm is a step-by-step procedure to solve a problem. Every problem can be solved using algorithms, and algorithm can be represented using two ways. One is a pseudocode, second one is a flowchart. Pseudocode is a English-like statements, easy to understand, easy to read, easy to write, but flowchart is a diagrammatic representation of the algorithm. Whatever algorithm you write, you can diagrammatically represent the flowchart using different symbols. Okay, that's all for today. So we will be coming with another new topic from next class. Thank you.